For our Group 4 project, we decided to examine how using different amounts of flour would influence the density of pancakes. Moreover, we wanted to see if the alteration of flour will affect how fluffy the pancakes turned out. We will use the formula for the volume of a cylinder to calculate the volume of the pancake and then apply the results in a density formula. But what does science say about pancakes and density? Density is an intensive measure of quantity. The quantity of a substance in physical chemistry is often measured by extensive properties like weight, mass, or volume. An intensive property is always the ratio of two extensive properties. The general meaning of density is the amount of something per unit volume. What is usually called density is more precisely known as the mass density, and this is what we will be measuring in our experiment. From a biological perspective, an important factor is the formation of gluten. Pancake batter is composed of two parts, dry ingredients and wet ingredients. Flour contains starch and protein. Starch is a long chain of simple sugars, and a protein is a long chain-like molecule made up of amino acids. Flour contains a protein called glutenine or gluten, which is crucial for the formation and structure of pancakes and baked goods. Gluten also provides the chewy texture in pancakes and breads. When the flour is dry, the gluten molecules are immobile. They also don't bond to each other. When the flour is mixed with water or milk and eggs, which are composed mainly of water, the gluten molecules become active. As the gluten proteins come in contact with one another, they bond. With additional mixing, the proteins create a tight network that traps air bubbles. When the pancake is cooking, the gluten network traps air bubbles and allows the pancake to rise and stay fluffy. From these scientific facts, our hypothesis was: flour decreases the density of pancakes, therefore the batter with the most flour will be the least dense and the most fluffy. The recipe we used for our pancakes was very simple. We used oil, eggs, flour, and milk. For each of the trials, we used 3 eggs and 250 milliliters of cow milk. To prove our theory, we needed to conduct multiple trials, and we decided to do 3. One with 100 grams of flour, one with 125 grams, and one with 150 grams. We mixed all of our ingredients and started cooking. The first batter with 100 grams of flour was clearly not ideal. The ratio of eggs to milk to flour wasn't balanced, and the batter wouldn't spread nicely on the pan. The pancakes were yellow instead of brown, indicating there was too much eggs, and the final product smelled more like scrambled eggs than pancakes. It was also hard to flip the pancake and keep it intact. We know already that flour creates gluten. Gluten molecules are plastic, meaning they can maintain their shapes after being stretched and moved around. Therefore, I believe this is why it was harder to keep the pancake whole. Overall, they were very dense and weren't fluffy at all. In the second trial, we used 125 grams of flour. These pancakes were far better than the previous ones. They spread nicely on the pan, they were easy to flip, the ratio was balanced, and no ingredient overpowered the other like eggs did in the first one. These were definitely fluffier. Interestingly, they were also much lighter than the first batch. The average mass was 75.33 grams, whereas the first average mass was 98.33 grams. The last trial, using 150 grams of flour, was definitely the best and fluffiest one. The batter was also the thickest, which confirmed a theory that was explored by the physicists at UCL, who, using the baker's percentage, which is the ratio of liquid to flour in batter, claimed that the thicker the pancake batter, the more craters there will be on the pancake. Here are 3 different pancakes, and it is very clear the last one has the most craters, which is also from the thickest batter. For each of the trials, we took 3 pancakes from each batch and measured the height, diameter, and mass. Using these measurements, we were able to calculate the volumes and apply that to measure the density. The first batch had a mass density of 0.55 grams per centimeter cube. The second was 0.46 grams per centimeter cube, and the last one worked out to be 0.41 grams per centimeter cube. Our initial hypothesis was confirmed, and the last batch with the most flour was the least dense and the fluffiest.